Find the limit. The limit of x squared divided by 1 minus cosine of x as x approaches 0. In this example, we would start off by doing the quotient rule. So we would be taking the limit of x squared as x approaches 0 divided by the limit of 1 minus cosine of x as x approaches 0. X squared and 1 minus cosine of x are both continuous functions, so we can calculate their limits by substituting in the 0. 0 squared, of course, is 0. Cosine of 0 is 1, is 1. So our limit using the quotient rule would be 0 over 0. That's an indeterminate form. And so we could try to do several things, but notice that there's really no way to get rid of the 1 minus cosine of x in the denominator. You can't factor and cancel. You can't rationalize the denominator. So one other tool that we have is LHopital's rule. So we can apply LHopital's rule here. X squared and cosine, 1 minus cosine of x are both differentiable functions. So we may use LHopital's rule. The derivative, LHopital's rule says you take the limit of the derivative of the numerator, in this case 2x, divided by the derivative of the denominator. In this case, that's going to end up being sine of x. Now we try the quotient rule again. So the limit of 2x as x goes to 0 divided by the limit of sine of x as x approaches 0. Again, those are both continuous functions, so we can substitute 0 in to calculate the limits. 2 times 0 is 0. The sine of 0 is 0. Uh-oh. We get another indeterminate form. Well, we're still in the case where 2x and sine of x are differentiable functions, so we might try to employ LHopital's rule one more time and hope that we get something. Notice that our power of x started off being x squared, so it's a power 2, and now we have a power of 1. So maybe if we do this one more time, we'll get rid of that. So the numerator, the derivative of the numerator is just 2, divided by the derivative of the denominator is cosine of x. So now notice that when we try the quotient rule, we take the limit of 2 as x approaches 0 divided by the limit of cosine of x as x approaches 0. We get 2 divided by the cosine of 0. The cosine of 0 is 1. So our limit actually ends up being equal to 2. So here we have found the limit, but we've had to employ LHopital's rule 2 times in order to get it done.